Let's take a look at using our graphing calculator to solve an application of quadratic functions. Let's read the problem. A baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second and at an angle of 45 degrees with respect to the ground. The path of the baseball is given the following function, and this is generated from the information that was given. I will not ask you to generate the function. So continuing, where f of x is the height of the baseball, so I want you to make sure that you underline that f of x, which we know is y, represents the height of the baseball, and also underline x is the horizontal distance from home plate. It is always important that you identify what f of x represents and what x represents. Lastly, I want you to underline what it is you're being asked to find. And this says, what is the maximum height that's reached by the baseball? So you're looking for the maximum height by the baseball. All right, so let's start out maybe trying to draw a sketch of what we've got going on here. It says a baseball is hit at a point 3 feet above the ground. So the person who's hitting the ball, their hand would be 3 feet above the ground. So we'll call this height 3 feet. And the pitcher pitches the ball, and the person hits it. And we know that when we hit a baseball, picture it in your mind at the ball field, it's going up, 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 and then at some point it's got to come down, down, down. So the batter, you know, stands at home plate. So I would let this point represent the batter's feet at home plate. And so this line would represent the ground. So this is home plate. Okay. We know we're looking for the maximum height reached by the ball. So I want you to follow through the pathway of the ball and put a point where you believe the maximum height to be occurring. So we're going, going, going. This looks like the maximum point approximately right here. So I'm going to put a point. Then I want you to label that as max height. Now think about, what do you know about this point as it pertains to the sketch that you've drawn? Well, I know this sketch, if I were able to let the pathway to the left of the bat fall to the ground, it looks like that I've just drawn a parabola. And the pathway of a ball being hit by a baseball is parabolic in nature. So this point that you just made would represent the vertex of the parabola. Now I know that you know that a vertex contains an x coordinate and it contains a y coordinate, which we also know could be called f of x. So let's look back at our definitions. F of x is the height of the baseball. X is the horizontal distance the ball traveled from home plate. So this dashed line that I'm drawing represents the distance the ball traveled from home plate, and this vertical dashed line that I'm drawing, let's just pretend that I lined it up perfectly with my max point. This would represent my height, which is what we've been asked to solve for. So we can say, after analyzing our picture, that the y-coordinate of the vertex represents our maximum height. And I want to show you how to find that by using your graphing calculator. So let's begin by, from the home screen, you can select the graph button to bring up a new graph. Or if you are already inside, let's say that you are inside just a regular page, you can select Control Document and then add a graph in that way. And in your f of x function, it already gives you what f of x equals. You have to type in the other side of the equation. So in this case, we would enter negative 0.0032 x squared plus x plus 3, and then press enter. Now, how we're zoomed in at the moment, this looks like a linear function. Well, we know this is could not possibly be a linear function because this is a quadratic equation. So let's go to Menu, Zoom Out, and I'm going to take my Zoom button and I'm going to put it at the origin and just press Enter several times until I've zoomed out enough. If I want to zoom more to the right, then drag your magnifying glass to the right and keep zooming until we can see the entire parabola. Once you've completed your zooming process, press the Escape button to get out of that. So we know that we're looking for this point right here, the vertex that represents our maximum height. To calculate that using your calculator, you can now select Menu, and we can do one of two things. I'm going to show you how to use Analyze Graph. When you select Analyze Graph, we have different options, and I'm going to use the maximum option because I'm looking for the maximum height. All right, this little hand that I'm scrolling back and forth from left to right, you want to do two things with it. First, this tells you to select the lower bound. So I'm going to slide to the left of my maximum point and then press Enter. Now it is switched and toggled to upper bound. So I'm going to slide to the right and then press Enter. And now it lists my maximum point. So my vertex point is 156 and 81.1. I can't tell you how many times I ask questions like this and students automatically give me the x coordinate for the maximum height. Recall, f of x represents the height, so our y coordinate represents our height. So the maximum height that the ball reaches is 81.1 feet. An alternate way you can find this point, let me back out of, let me see if pressing escape would get rid of it. Let me get rid of this point. Okay, so to get rid of that point, I selected it and then pressed delete. Another way to find that point is to select Menu, and rather than Analyze Graph, I can go to Trace, Graph Trace. Now I can toggle left and right, and when I get to the max point, the little, let me try that again. Sometimes the word maximum will pop up. It really depends on your settings, so you can watch your y coordinate here. If I'm toggling left and right, my y coordinate is 80.3, then 80.7, it's still getting larger, 81, still getting larger, 81.1, still getting larger. The next time I press it, it's still 81.1, and I can keep adjusting it until I see if it's going to keep going up or down. So that's another way to find your maximum.